The distributive property states that a times parentheses b plus c is equal to ab plus ac. In this case, we expanded out an expression with a product involving parentheses into a sum of terms without any parentheses. Factoring polynomials is the reverse process of the distributive property, where an expression is rewritten as a product of polynomials. Since a times parentheses b plus c is equal to ab plus ac, it stands to reason that we can go back and say that ab plus ac is equal to a times parentheses b plus c. We will use this formula to factor polynomials. The idea here is that ab and ac have an a term in common, and we factor out the a to rewrite ab plus ac as a times parentheses b plus c. We will apply this principle to factor polynomials in the next few examples. If we want to factor the expression 12x squared y plus 6xy squared, we need to find the greatest common factor for 12x squared y and 6xy squared. What do the two terms have in common? If we look at the coefficients, we see that the greatest common factor between 12 and 6 is 6, so we have to factor out a 6. We have an x squared in the first term and an x to the 1 in the second term, so we can only factor out an x to the 1 from both terms. We have a y to the 1 in the first term and a y squared in the second term, so we can only factor out a y to the 1 from both terms. Therefore, the greatest common factor is 6xy, and we should factor out a 6xy from both terms and put it outside the parentheses. To determine what should go inside the parentheses, we divide each term in our original expression by the greatest common factor we factored out. So we take the first term, 12x squared y, and we divide that by 6xy, which is the greatest common factor. And we get a 2x, which is the first term inside the parentheses. Similarly, we take the second term, 6xy squared, and we divide it by our greatest common factor, 6xy, which results in a y, which is the second term inside the parentheses. So this is the answer, and this is the factored form of our original expression, and we can check to see that this is indeed equivalent to our original expression by applying the distributive property and multiplying it out again. So if we take 6xy and multiply that by 2x plus y, well, we get 6xy times 2x, which is equal to 12x squared y. And if we take 6xy and multiply that by y, we get a plus 6xy squared, which is indeed our original expression. And this is a good way to check if we have done our factoring correctly. So now let's try another example. Let's try to factor 30x to the fourth y squared plus 6x squared y to the fourth. What is the greatest common factor between the two terms? If we look at the coefficients, 30 and 6, the greatest common factor between the two is 6, so we need to factor out a 6 from both. There's an x to the fourth in the first term and an x squared in the second term, which means we can factor out an x squared from both terms. And since there's a y squared in the first term and a y to the fourth in the second term, we can factor out a y squared from both terms. So now we need to take both terms and divide that by the greatest common factor 6x squared y squared to determine what goes inside the parentheses. If we take 30x fourth y squared and divide that by 6x squared y squared, then we get a 5x squared, which is the first term, in the parentheses. If we take the second term, 6x squared y to the fourth, and divide that by 6x squared y squared, we get a plus y squared, which is the second term inside the parentheses. And this is our final answer. So now let's try another example with less intermediate steps. Let's try to factor the expression 5x sixth y cubed plus 15x squared y to the fourth. Once again, we need to take out the greatest common factor from both terms. If we look at the coefficients 5 and 15, the greatest common factor between the two is 5, so we need to take out a 5 from both terms. since the first term has an x to the sixth and the second term has an x squared, we need to look at the lowest power for x in both terms, which is the x squared, and that's what we need to take out from both terms. And similarly, if we look at the y cubed in the first term and a y to the fourth in the second term, the lowest power is the y cubed, so we can take out a y cubed from both terms. And to determine what goes inside the parentheses, we need to divide each term by the greatest common factor, which is 5x squared y cubed. So if we divide 5 by 5, then we get a 1, and we have an x to the sixth in the first term, and if we divide that by x squared, we get an x to the fourth. And if we take a y cubed and we divide that by y cubed, then that's just a 1. So the first term is just simply x to the fourth. And if we look at the second term, 15x squared y to the fourth, and we divide that by 5x squared y cubed, well, 15 divided by 5 is just the coefficient 3, and then x squared divided by x squared is just 1, so there's no x term in the second term in the parentheses. And if we take a y to the fourth and divide that by y cubed, then that's just a y. So the expression inside the parentheses is just x to the fourth plus 3y, and this is our final answer. The principle of the reverse distributive property can be applied to expressions with more than two terms. So if we try to factor an expression with three terms, like 12x to the fourth y cubed plus 6x to the fifth y squared plus 3x squared y to the fourth, we simply need to find the greatest common factor between all three terms. So if we look at the coefficients 12, 6, and 3, the greatest common factor between all three is simply 3. So we need to factor out a 3 from all three terms. And if we look at the x variable, we can see an x to the fourth in the first term, an x to the fifth in the second, and then an x squared in the third term. So if we look at the lowest power, which is the x squared, that's what we can factor out from all three terms. So we need to factor out an x squared, and then if we look at the y variable, we have a y to the cubed, a y squared, and a y to the fourth, so we can only factor out a y squared from all three terms. And therefore, 3x squared y squared is the greatest common factor for all three terms. So to determine what goes inside the parentheses, we need to divide each term by the greatest common factor. So if we take the first term, 12x to the fourth y cubed, and divide that by 3x squared y squared, we will get a 4x squared y. And for the second term, if we take the 6x to the fifth y squared and divide that by 3x squared y squared, we will get a plus 2x cubed. And if we take the third term, 3x squared y to the fourth, and divide that by the greatest common factor of 3x squared y squared, we simply get a y squared. And this is our final answer. So now let's look at a slightly harder example. Let's try to factor 4x squared y squared z plus 6x cubed y to the fourth z squared plus 12x cubed y cubed z cubed. So in this example, we have three terms and three variables to consider. So we apply the same process of finding the greatest common factor between all three terms while taking the x, y, and z variables into consideration. So if we look at the coefficients first, the greatest common factor between 4, 6, and 12 is 2, so we can factor out a 2 from all three terms. If we look at the x variable, we have an x squared in the first term, an x cubed in the second term, and an x cubed in the third term, so that means we can only take out an x squared from all three terms. If we look at the y variable, we have a y squared in the first term, a y to the fourth in the second term, and a y cubed in the third term, so we can take out a y squared from all three terms. And if we consider the z variable, we have a z in the first term, a z squared in the second term, and a z cubed in the third term, so that means we can only take out a z variable from all three terms. So this means the greatest common factor for all three terms is 2x squared y squared z, and that's what all three terms have in common. So again, if we want to find what should be inside the parentheses, we divide all three terms by the greatest common factor, which is 2x squared y squared z. So if we take the first term, 4x squared y squared z and divide that by 2x squared y squared z, we get a 2 constant term. And then if we take the second term, 6x cubed y to the fourth z squared, and divide that by 2x squared y squared z, we get a plus 3xy squared z. And if we take the third term, 12x cubed y cubed z cubed, and divide that by 2x squared y squared z, we get a 6xy z squared. And this is our final answer.